Given the following array of integers, what is the result of the quicksort algorithm for the original partition prior to the recursion? The purpose of this problem is to reinforce that the original partitioning is where we gain the benefit because it allows us to significantly reduce the number of recursive calls, which is why quicksort is beneficial compared to bubble sort or merge sort. So we have 19, 10, 12, 21, 7, 18, and 3. The partition is set to the leftmost value. The next value is the left arrow, and the right arrow is here. We move the left arrow until we find a value that is greater than the partition. So we go to 10 to 12 to 21. We move the right arrow until we find a value that is less than the partition. So we have already found it. At this point, we now know that the value at left is greater than the value at right. So we swap. We do the same thing. So here we're going to move, and we find 21. And then, so now this is left. And then we move right until one of two things happens. Either we find a value that's less than the partition, or we find a value where we cross the pointers. And we have done both here. Right is currently pointing at 18, and 19 is the partition. The last step is we should swap the values if the right value is less than the partition. So we're going to move 18 here, and we're going to move 19 here. So therefore, the answer is 18, 10, 12, 3, 7, 19, and 21. And so that is A.